Okay, welcome to this video where we're going to be having a look at the AQA Paper 1 Foundation Checklist for the 2022 GCSEs. Now, as you can see on the screen, this is the checklist with all the topics. These are all the topics we're going to be looking at throughout the video, and these are all the topics that have been advised by the exam board. Now, if you want to download this, I'm going to show you where to download it, but obviously we are going to have a look at all of these, so we've got quite a lot to get through. Now, with all of these different videos, obviously, I'm only going to be going through one of each type of question. So you will need to do a little bit more revision for each of those questions, particularly the ones that you don't know as well. And to do that, I'm going to show you where you can find full lessons on each of these topics as well. So let's have a look at that now. So when you're on the video, if you haven't seen one of these before, if you click into the description, right at the top, you can see that there are two links. So you can download the checklist in that top link where it says the Higher and Foundation Revision Checklist. Just make sure you pick the right exam board, and you've got the practice booklets that you can download as well. You can print them off, follow along with the video, or you can just practice those papers after you've watched this video as well. If you scroll down, you've got all the links to all the videos, and then down the bottom, next to each of the topics that I go over, you can see there's a link next to each of those topics. You can click on that link and you can watch a full lesson with practice questions going over each and every one of the topics in the video. As well as that, while you're going through the video, if you just want to skip through chapters or look at particular areas, if you pause the video and click on the chapters button in the bottom left there, this is on products of prime factors at the moment, it'll open up all the chapters and you can see I've broken down the video so you can see exactly what is in the video, where it is, and you can kind of skip through, I don't know, the night before the exam, maybe you want to just quickly have a look at particular topics that you remember from the video, and you can do that quite easily just clicking through that way. So there we go, as I said, we've got a lot to get through, so with that being said, let's get started. Okay, so when looking at order of operations, we just need to think about those rules and the orders in which we do things. So for part A here, it says work out 2 times 5 plus 7. That's a really nice one because multiplication comes before addition. So in this particular question, we would do multiplication first, which is 2 times 5. So we'd have 10 for the answer for that, and then we'd need to add 7. And when we do 10 plus 7, we get the answer 17. So that's hopefully quite a nice one. Now for this one here, it says write brackets in this statement to make it correct. So at the moment we have 7 times 2, add 3, and that equals 35. Now if we were to follow our normal rules here, 7 times 2 would equal 14, then we would add 3, and that obviously doesn't equal 35. So it doesn't work as it is, and that means there's only one place for us to put the bracket, and that would have to be around the 2 plus 3. Of course, no matter which one you're given, you do need to check this out and just make sure that it is correct. So we do brackets first. 2 plus 3 is equal to 5. So actually we're going to be doing 7 times 5, and 7 times 5 is 35. So we're happy with that. We know it's correct, and we've checked our answer. So that's how we go about doing order operations. Okay, so when looking at some negative numbers, we can have any form of calculation or any kind of question to do with negatives, but here's an example with something to think about. So it says write one of these numbers in each space to make the correct calculation. So you just need to remember whichever number we put first here is going to be our starting number. So if we want -7, it's probably a good idea to try something down in the negatives. So if we were to put -9 here, what would we have to add to -9 to get -7? Well, if we're going to add something to -9, we're getting closer to 0 to get to -7. So we don't want to be adding a negative, we want to add a positive. So if we could add 2, and that would get us to -7. So that's one of our solutions there. But is there anything else we could have tried? Well, if we had have started with -2, we'd have to add -5 to get down to -7, so we couldn't have started with -2. What about if we started with 2? Is there any way we could have got down to -7? Well, we can add -9 to 2, because if we do 2 add -9, that would be the same as 2 take away 9, and 2 take away 9 would equal -7 as well. So we could have had -9 add 2, or we could have had 2 take away 9, which would have been equal to -7. And in each of these questions, whenever you're dealing with negative numbers, you just got to remember your starting number and then whether you are going up or down. So if you're adding a positive, you'll go up closer to 0, or obviously above 0, and if you're adding a negative, that's actually going to be doing a takeaway. So just be careful there with your starting number and which direction you're going when you are adding or subtracting negatives. Okay, so in this question we've got some estimation. It says here, Paul organised an event for a charity. Each ticket for the event cost £19.95 and he sold 395 tickets. Paul paid costs of £6,000 and he gave all money left to the charity. Work out an estimate for the amount of money Paul gave to the charity. Okay, so let's have a think. Now he's got the tickets for £19.95 and we are going to do an estimate here, which means we're going to round all our numbers to one significant figure. So for the amount of money or each ticket, we're going to round that to £20. So we'll write £20 for that. And he sold 395 tickets. So let's round that. We'll just label it here to 400 tickets. Now, just as a side note here, if you don't round them, you can still get the answer correct, but bearing in mind we're doing a non-calculator method here, we don't want to waste any time doing £19.95 multiplied by 395 tickets when we could just do this nice easy method of using our one significant figure rounded numbers. But again, you can do it the other way, doing the full calculation, but you're going to spend a lot more time doing that. You're not going to gain any extra marks. So for this one here, if we've got 400 tickets, each one was £20, well, we're going to do 400 tickets multiplied by the £20, which is easy for us to do because we just do 4 times 2, which is 8, and then add on those 3 zeros. So that's £8,000. So he sold £8,000 worth of tickets and he paid costs of £6,000. So that means he's made £2,000 profit, because if we take the £8,000 that he made selling the tickets, take away the £6,000 costs that he had to pay, that's left him with a profit of £2,000. And that £2,000 is what he's going to give to the charity. So it says he gave all money left to the charity, so that £2,000 which he would have made, he's given it all to the charity. Now it says here, is your answer to A an underestimate or an overestimate? Give a reason for your answer. Now in our calculation we've done a multiplication, so we've multiplied 2 numbers together. So what have we actually done to our numbers? Well, we rounded the cost of the ticket up from £19.95 to £20. We've said they're more expensive, and we've rounded the amount of tickets up from 395 to 400. So we've said more tickets and a higher price. So that is going to be an actual larger number there that we got for the 8,000. So actually he would have made slightly less than £8,000, and then when we took away the 6,000 we'd have had a number less than the £2,000. So our answer is an overestimate, and we would have to give a reason for that. So our reason there would be that because we rounded both the numbers up, it's given us a bigger number when we worked out this 8,000. So 8,000 was more than it should have been. So therefore it's an overestimate. And there we go, there's a bit of estimating. For the first one, we've got work out 3 4/5, add 3/7, and give your answer as a mixed number in its simplest form. Now when we're looking at this sort of question here, one thing we need to remember, no matter which type of calculation we're doing, adding, subtracting, dividing or multiplying, if we have mixed numbers involved, we need to make them top heavy first. Now when it comes to adding and subtracting, there is a little bit of a different approach that you can take that some of you may use, but I'm going to use the same method for all of these types of questions, and that is making any mixed numbers top heavy fractions first, or improper fractions first. So the process for doing that is obviously taking our fraction here, 3 4/5, we want to turn that into an amount of fifths. So to do that, we want to figure out how many fifths are in 3. So we can do 3 times 5, which is 15. Add the extra 4/5 there, and that makes 19 fifths. So 3 4/5, 3 times 5 is 15. Add the 4 that we've got there as well is 19 fifths. Okay, so it's the big number times the bottom to make 15, add the top number on the fraction there, 19, so we've got 19 fifths. And we're going to add that to the 3/7. Now when it comes to adding and subtracting, we need to have a common denominator. So we need that number on the bottom to be exactly the same. Now that means that we can multiply both fractions here. As long as we do whatever we do to the bottom, we also do to the top. We can make equivalent fractions with a common denominator. So thinking about 5 and 7, the lowest common multiple of those is 35. So in order to get them to be 35, the left fraction there, I can times the top and bottom by 7. And the right fraction, we can times the top and bottom by 5, and that would give us 35 on the bottom of both. So we've still got to work out 19 times 7 there, and obviously take your time doing so, but 19 times 7 is 133, and at the moment that is going to be over now 35. Okay, so you get some quite big numbers here, but obviously don't be afraid just to the side to do some multiplication there. I did 7 times 10 and 7 times 9 and added them both together, okay, but you can show you working out to the side. On the right fraction there, we're going to times them both by 5, so 3 becomes 15 and 7 becomes 35. And now we're in a position where we can add these both together. So we can just add together the numerators, 133 plus 15, which gives us 148. And that is over 35, remembering that you don't add together the denominators. There we go, we've got 148 35ths. Now obviously it says here to give your answer as a mixed number in its simplest form. So it's up to you whether you try and simplify this or whether you so obviously turn it into a mixed number first, but we need to turn it back into a mixed number. So to do that I need to know how many times does 35 go into 148. That's not the nicest, so I'm just going to write down a few of the 35 times table. So 35, add another 35 is 70, add another 35 is 105, add another 35 is 140, and then it's not going to go beyond 140 there because obviously our number there is only 148. So to go from here, we know that 35 goes in 4 times, so that's going to be a big 4. And what's left over from 140 to 148 is an additional 8 35ths. There we go, so 4 and 8 35ths left over. Okay, so looking at that number there, you've just got to decide as well, does that little fraction at the end there simplify? Does 8 over 35 simplify? Now in the case of this fraction here, it actually doesn't. There's nothing that goes into both 8 and 35 other than 1, and obviously that's not going to simplify it for us. So that actually is fully simplified there. So even though it says give it in its simplest form, in this circumstance here, that little fraction on the end there doesn't simplify, okay? But it's going to say that anyway because we didn't have to use 35 as our denominator. We could have potentially used a bigger number like 70 or even larger if we wanted, but because we used the lowest common multiple, it's just ended up that doesn't actually simplify at the end there. But do look out for that because that fraction quite often does need simplifying, okay? But there's our final answer, 4 and 8 over 35. Let's have a look at some subtracting. Right, okay, so this question says 2 1/7 take away 1 1/4. Okay, work that out and give your answer in its simplest form. Now it doesn't mention anything about it being a mixed number, so that obviously gives us a bit of a hint that we're not going to have a mixed number here. We're just going to go about this process in exactly the same way as when we were adding, okay? Adding and subtracting, the process is the same, except obviously we're not going to add our fractions together at the end, we're going to take them away from each other. So we're going to make them top heavy to start with, turn them into improper fractions. So 2 1/7, 2 times 7 is 14, add the 1 is 15 over 7. And the 1 on the right, and we're obviously taking these away. 1 times the 4 is 4, add the extra 1 on top there is 5/4. And there we go. And we just need to make these have a common denominator. And again, we'll look for the lowest common multiple here. So 7 times 4 is 28. That does actually give us the lowest common multiple there. So we're going to make the denominators out of 28. So we're going to times the right fraction by 7. Okay, that's top and bottom. And we're going to times the left fraction by 4. And again, that's going to be top and bottom. So our two fractions are going to be out of 28, so I'm just going to write two blank fractions here. I know what the denominators are going to be. I just need to figure out those numerators. So 4 times 15 on the top of the left one gives us 60. And 5 times 7 on the top of the right one gives us 35. There we go. So we've got 60 over 28, take away 35 over 28. So again, the denominator isn't going to change. We're just going to write how many 28s we have left. But 60 take away 35 there leaves us with 25. There we go, so that is our final answer there. We get 25 over 28, sorry. Okay, so again, just having a quick look, does that simplify? Are there any numbers that go into 25 and 28? No. Okay, 25 divides by 5, 1 and 25, and none of those apart from 1 obviously go into 28, so it doesn't simplify. So again, it says give your answer in its simplest form, but again, we got the lowest common multiple there for the denominator and made sure that they're the ones we use. So a little hint for you there is always look for that lowest common multiple, okay? In the case of these two, they were quite nice because it was just the two denominators times together, but you always want to have a look for that lowest common multiple just to avoid having to do that simplifying at the end there. For this one, we are going to work out 3/5 of 65. So again, just like before, to start with, we are going to work out 1/5. So to get 1/5, we're going to divide by 5. So for 1/5, we're going to do 65 divided by the denominator there, which is 5. And again, if you're not sure on that, just do some division to the side. You might know how to do that mentally if you want, but 5 goes into 6 once, remainder 1, and into 15 3 times, so there we go, the answer is 13. So 65 divided by 5 is 13, and that's 1/5. And then again, flipping to the numerator, because we want 3 of those, so we're going to times that by 3. So for 3/5, we are going to take the 13, multiply it by 3, and that gives us an answer 39. And again, you can do your working out to the side if you need to for any of those. But there we go, that's how we're going to work out a fraction of an amount. So divide by the denominator to get one of them, whatever that denominator may be, and then multiply by the numerator, and that's going to give us our answer for working out whatever fraction we're looking for, whether it be 2/7, 4/9, 3/11, whatever it would be. So divide by the denominator and then multiply by the numerator. Okay, so this question says 3/5 of a number is 48, work out the number. So this really tends to confuse people when it does come up, because obviously when you see 3/5 of a number, a lot of people are going to think, okay, straight away divide by the bottom times by the top. But this is actually in reverse. This is saying that 3/5 of a number is already 48. And if we think about this in terms of our bar again, let's just think about if we had split this up into 5 portions this time, because it is in terms of fifths. There we go. So if I split this up into 5 parts, which I may not get perfect, there we go, good enough. And what it's saying is that 3 of them has already been calculated as 48. And we want to know what the entire original number is. So looking at this then, okay, well, if only 3 of them were 48, well, we wouldn't divide by 5 anymore, but instead we would divide by 3, because we want to know how much is going to go into each of those 3 boxes just above. So this time, and it's obviously the complete reverse of before, because this time we're going to divide by that numerator. So instead we're going to divide it by 3, and that's going to tell us what number goes into each of the bars above. So 48 divided by 3 is equal to 16, and again you can put that, obviously the working out, just to the side. So if I put now 16 into each of these bars, I would also put it into those additional 2, because we are looking at now all 5 of them. So that number there, if we add up all of those 16s, and again, you can obviously add them all up, or you can do 16 multiplied by 5. So that working out I would do to the side, 16 times 5, because there are 5 boxes, and that adds up to 80. There we go. And that is my answer. And again, you could put the 80 next to your diagram if you prefer to use a diagram method, but that is how we're going to go about approaching these questions. So if you think about what we've actually done, it's just the complete opposite of what we did before, and that's why it's in reverse. This time instead we are dividing by the numerator and multiplying by the denominator. But you need to understand why, and I think that this visual idea really does help you to understand why we would divide this time by the numerator and why previously we were dividing by the denominator. Okay, so this is a bit of a special one. It says write down the value of 3 squared times 3 cubed all over 3 to the power of 5. Let's just have a look what we get here. So if we tidy up the top, adding the powers, we get 3 to the power of 5 on the top. And that's also being divided then by 3 to the power of 5 on the bottom. Now it says write down the value. If I think about what this is as a power of 3 though, if it's a power of 3, 3 to the power of 5 divided by 3 to the power of 5, we subtract the powers. So that's 5 take away 5, and 5 take away 5 is 0. So 3 to the power of 5, take away 3 to the power of 5 gives me 3 to the power of 0. Now 3 to the power of 0 here is a special one when we've got something to the power of 0, because if we think about what we've actually got here, we've got a number on the top, and it's being divided by the same number on the bottom. And what happens when you divide any number by itself? Let's just think of an easy number, just 3 on its own. 3 divided by 3 gives us the answer 1. Anything divided by itself equals 1. So therefore, 3 to the power of 0 must equal 1. Okay, and this rule applies for everything here when we've got something to the power of 0. Anything to the power of 0 is going to equal 1. It doesn't matter what I pick, whether I pick 5 to the power of 0, that's going to equal 1. I could pick anything, 49 to the power of 0, that also equals 1. Okay, just thinking about this logic here of anything divided by itself has to equal 1, and that's how we get a power of 0. So I'm not going to give you any questions on this, but it's another little rule to have a bit of a think about. If you are asked to find something to the power of 0, the answer is always 1. And just be careful not to mistake that power of 0 as a degree symbol. It's not, it's a power of 0 there. Okay, so write down the value of 4 to the power of negative 2. Now the negative part's still going to do the same thing, so we're still going to do the reciprocal. So 4 again is not a fraction, so we'll write it as 4 over 1, and the reciprocal of that is 1 over 4. Now this actually has a negative 2 in there, so that 2 is just a normal power. Okay, so the 2 is just a normal power of 2, and when we do a power of 2 we square what we've got. So when we're squaring a fraction, we are just going to square it like we would a normal number, except we're going to square the top and we're going to square the bottom. So the square of 1, 1 squared, 1 times 1 is still 1, and the square of 4, 4 times 4 is 16. So there's our final answer, 1 over 16. So a negative power flips it over, the number is just a normal power. Right, so write down the value of 125 to the power of a third. So again, 125 to the power of a third. We have this number on the bottom, which is the root, and a 3 would represent a cube root. Again, it's just a 1 on the top though, which is a normal power of 1, and a normal power of 1 does not change our number at all, so a normal power. But a cube root, let's write that in, so that would represent the cube root of 125. So it does help to know your square and cube numbers here. 125 is a cube number, and the cube root of 5 is 5. There we go. Remember, you can always think about that backwards. You can think, okay, well, 5 times 5 is 25, times 5 again is 125, so the cube root of 125 is 5. So when you're doing these fractional powers, just look at what number's on the bottom. That could be a square root, a cube root. We could have a 4 on the bottom, and that would be a 4th root. We could even have a 5 or numbers beyond. Okay, so a bigger number here, 504,000 in standard form. So there isn't a decimal in this number at the moment, but the decimal would be here at the end if we had one. So if we think about where that decimal would be if we were to write it, to write this in standard form, we'd have to do quite a few hops here. So 1, 2, 3, 4, 5. Okay, so that's 5 hops for this number, and that would make the number 5.04. Okay, not forgetting that that 4 exists, we can't just not include that, it's still there. So 5.04 still times 10, and that was 5 hops. It's a big number, so 5. Okay, not a negative power for this one because it's not a 0 point number, it's a large number. So 5.04 times 10 to the power of 5. So just remember, if it's a large number, you're going to have a positive power with however many hops you've done to make it between 1 and 10. And if it's a 0 point number, you're going to have a negative power again for however many hops you've done to make that number between 1 and 10. Okay, 8.03 times 10 to the minus 5. So it's a negative 5 there in the power, so it's going to be a 0 point number. So I'm going to have to hop it the other way this time. So let's write out what we've got so far. We've got 8.03. So the decimal is already drawn in for us, it's just in there. So we're going to hop it from there to the left to make sure it's that 0 point number because it's a negative 5 as the power. And we're going to do 5 hops. So 1, 2, 3, 4, 5. And then let's fill in these zeros and put that decimal in there where it's going to go now. Now we've got this number here. Obviously we just need to tidy this up because we would normally write this with a 0 at the front. So tidy that up with a 0, and let's rewrite actually what we've got here. So we've got 0.0000 and then 803. And that is my final answer there for writing that as an ordinary number. So just remember, if it's a positive power, we're going to hop it to the right to make sure it's a big number, and if it's a negative power, we're going to hop it to the left to make sure it's a 0 point number, a little number there. Okay, so looking at this one, 4 times 10 to the 5 times 3 times 10 to the minus 2, and this is an example of one where we probably wouldn't want to write this out as ordinary numbers and work them out because it might get a little bit overcomplicated here. But let's look at applying that same little trick. So let's do the 4 times the 3, which gives us 12. And that's going to be times 10 to the power of something. I've just got to be a little bit careful here because although we can add these powers, let's just have a look because one of them's a negative. So the powers, if I write this to the side, we're going to do 5, the first power, and we're going to add the next power, which is negative 2. And 5 plus negative 2 is 5 take away 2, so my power there is going to be 3. So that's fine, 12 times 10 to the power of 3. And again, we just need to put this in standard form because this 12 is not between 1 and 10. So instead we'll make that one jump smaller, we'll make it 1.2, and to balance that out we'll make the power one jump bigger, so 3 goes up to 4. And there's our final answer, 1.2 times 10 to the 4. One more question before we have a go. So 4.3 times 10 to the minus 5 times 3 times 10 squared, again giving your answer in standard form. So we can apply the same little trick again. We've got 4.3 times 3. If you've not got a calculator here, we could just add together 3 4.3s. We're timesing it by 3, so 4.3, 4.3, and another 4.3, 3, 6, 9, and then 4, 8, 12. So we get 12.9. So 4.3 times 3 is 12.9 times 10. And let's figure out what that power is going to be. So that first power is negative 5, and we're going to add 2 to that. So negative 5 add 2 is negative 3. So my power there is going to be negative 3. Again, it's not in standard form though, so I'm going to have to balance it out. So I'm going to make the number one jump smaller, down to 1.29. I'm going to make the power one jump bigger. So bigger than negative 3 is negative 2, getting closer to 0 there. So there's our final answer. Just following the same process, building it up in difficulty, we did 4.3 times 3. I used a little bit of working out to the side, which is absolutely fine to do. Then we balanced it out, so we made the number at the start one place value smaller, balanced it with making the power one jump bigger. Just watch out there when it is a negative power there, making it one bigger would not go down to negative 4, that would be going smaller, so we are going up to negative 2 to make it bigger. Okay, so in this question we just need to put some symbols in the correct boxes. So it says here are the symbols, and we have the less than symbol, the greater than symbol, and the equal to symbol. Write one of these symbols in each box to make the 4 true statements. So 14 is less than 21, so we can put the less than symbol in there, that one's okay. Now this one here we're going to have to work out, so 4 plus 7 is equal to 11, and 103 take away 92, well that is also equal to 11. So that statement there, they are equal to one another. For the next one we've got 2 squared, 2 times 2 is 4, and here 2 times 2 is 4 as well, so again that's equal to one another. And then for our final one, negative 3 and negative 5. Well, negative 3 is greater than negative 5, it's closer to 0, so it's a bigger number. And there we go, there is filling in symbols where we're using inequalities. Okay, so when we're looking at some systematic listing, it says here Jennifer's going to have a meal. She can choose one starter and one main course, and then we've got our 3 options for the starter: pate, melon or ham. And for the main course, let's just highlight that in a different colour, we've got beef, salmon or lasagna. So it says write down all the possible combinations Jennifer can choose. And that word systematic listing means we're going to make a list in a system or a systematic way. That means quite basically a logical way. We're going to use a system to create it. So we're going to start off by picking the first starter, and I'm just going to use the first letters, and let's just check to make sure they are all different letters. Yes, they are. So for the pate as the starter, we would then have a main course of beef, or we could have the pate starter with a main course of salmon, or we could have the pate starter with a main course of lasagna. So the system that I'm using is I'm starting with the first starter and matching it up with all the main courses. Now that I've matched it up with all the main courses, I would go on to the next starter, which is the melon. And again, I'm just going to match that to all the same main courses above. So melon with beef, melon with salmon, and melon with lasagna. And then I'll go on to the final one, which was ham. So ham and beef, ham and salmon, and ham and lasagna. And that is all of our possible combinations there, and that is completed. So we've used a nice system to create this list. Okay, so that's how we go about using systematic listing. Okay, so when looking at some length conversions, we need to remember for this first one where it says to change 450 centimetres into metres, how many centimetres are in 1 metre? So there are 450 here that we need to convert. Now in each metre there are 100 centimetres, so we've definitely got more than 1 metre here, but we could actually just divide it by 100. If you can't just spot this answer, divide it by 100, that would hop the decimal to here, and that'd be 4.5. So for this one here, we would say 4.5 metres, and that would be our first answer. For the next one, we're going from metres to millimetres. That's quite a big conversion there. So to start with, rather than jumping straight from metres to millimetres, let's go back from metres to centimetres. So 9.4 metres, if we want to turn that into an amount of centimetres, again, we'll just do the opposite of what we've just done, which is multiplying by 100. So if we hop the decimal over twice, that would be 940 centimetres. Now this next conversion relies on you knowing how many millimetres are in a centimetre. Of course, if you have a ruler, that's quite nice and easy to remember because you can look at your ruler. But there are 10 millimetres in every 1 centimetre. So we would times that by 10, and that would turn it into millimetres. So that would be 9,400 millimetres. Now, of course, you might have spotted there, if we are timesing by 100 and then timesing by 10, then we could have actually just multiplied by 1,000, but that's going to give you a lot of conversions that you need to remember. So I would prefer to just remember the conversion between meters and centimeters, and then also centimeters to millimeters. But there we go, that's how we go about some length conversions. Now, when it comes to all of these percentages, my first step is always the same, and that is to work out 10%. So to start with here, we're going to write down what 10% is. So 10% is nice and easy for us to find. You take the number, which in this case is 80, and you just divide it by 10. And that just means essentially you can do your little trick, which is to hop the decimal in. So if you hop the decimal in over the 0, you get that 10% is equal to 8, which is always very nice when it does end in a 0. Because obviously you can apply the trick, which is just to get rid of the 0 there. But 10% is 8, and now we need to figure out how we're going to get to 35%. Now, because there's a 5% in there as well, we're also going to have to find a 5, and that's easy enough now that we have 10%, because we can just halve 8, and that would give us that 5% is equal to 4. We now have everything we need in order to build up to 35%. We know that 10% is 8, so if we want to get to 30%, we would want to have 3 of those, and the additional 5% there, which would get that up to 35% in total. So you can apply different methods here in order to get to 35%. You could either just add together the pieces that you need, or you could do some multiplication as well. And what's a nice easy method that you can do is just say, okay, we want 3 of the 10%, so 8, another 8, another 8, and a 5%, which is a 4, and just add them all together. Okay, you might argue actually it's a bit easier just to times 8 by 3, but we get 8, 16, 24, plus the 4 is 28, and that would be our final answer, 28. So there we go, nice and easy. Okay, so this question here then, we've got a lot of information. It says, on Saturday, some adults and some children were in a cinema. It says the ratio of the number of adults to the number of children was 5:2. And each person had a seat in standard seating or had a seat in the premium seats. 3/4 of the children had a seat in the premium seats, and 117 children had a seat in the standard seats. And there are exactly 2,600 seats in the cinema. Let's just highlight that in a different colour. And it says, on the Saturday, were there people on more than 60% of the seats? So there's a couple of different ways that you could approach this. What we could do is we could straight away work out that 60%, which seems a little bit counterintuitive as it's the last line in the question. But if we work out that 60% straight away, we'll know what kind of number we're aiming for here. So we could work out that 60%. And again, depending on whether you are using a calculator or not will depend on how you approach that. But if we do that without a calculator, because that's relatively simple for us to do, we can just work out this 60% to start with. So 10% would equal 260, and then we times that by 6 to get our 60%. And if we just do that using column multiplication, just to get our answer nice and quick, 6 times 0 is 0, 6 times 6 is 36, and 6 times 2 is 12, so that's 1,560. Now on a question like this, you never know in an exam, that may have just got you a mark. So well worth working that out if that's the nice easy step to go for this question. So let's get rid of that, and obviously always leave your working out again, but we'll get rid of that and we'll just have a look at going back to the start. So it says adults to children was 5:2, and then it gives us some information about where they sat. We know that 3/4 of them had seats in the premium seats and 117 children were in the standard seats. Now both of those bits of information are just about the children. So if 3/4 of them were in the premium seats, the other quarter must have been in the standard seats. And it tells us that that was 117 children. So we'll know if this one is 3/4 and this one was 1/4, because it's the rest of the children, and it tells us that that 1/4 is equal to 117. We just want to know what the 3/4 is equal to. And we know if 1/4 is 117, in order to get 3/4, we just have to multiply that by 3. So if we multiply that by 3, that is going to tell us the amount of children that were in the premium seats. So 117 times 3, and again, you've just got to do some working out. Again, you can either multiply it by 3, or you could just add that together 3 times, whichever you prefer. I'm going to use a combination of methods here. So that adds up to 21, that adds up to 5, and that adds up to 3. So that is 351. So we know that there are 351 children that are in the premium seats. Let's get rid of that working out because we now have quite a lot of information. We know that the first thing we worked out, we're trying to see if they filled 1,560 seats. And now in this second bit of information, we've actually worked out the total number of children. We have 351 that are in the premium seats and 117 that are in the standard seats. So if we add those both together, we have 8, 6 and 4, so 468 children. Now we obviously just want to work out how many adults there are. So we know that there are 468 children, but how are we going to get to the adults? So it tells us the ratio of adults to children at the start, just over here, and it tells us that the ratio of adults to children is 5 to 2. And we've already worked out that the children in that ratio is 468. So we're using a different part of our ratio here. We're not just sharing in a ratio, we're actually working backwards because we've already been given one of the numbers. So in order to get back to one part, we could divide that by 2. And that would allow us to then figure out the other way around what we would have to have multiplied by, and essentially to get our number down here to figure out the amount of adults. So if I want to work that out to the side, I can do 468 divided by 2, which tells me what one part would be worth, and that answer comes out as 234. So we must have multiplied by 234 per part in order to share that ratio out. So times 234. So that means in order to get the total amount of adults, we're going to have to times by 234. Again, if this is non-calculator, you're going to have to do some working out there. Or you could just apply a little bit of a trick for timesing by 5, which is to times by 10 and halve it. Although you might argue it's probably just quicker to do 234 times 5 to the side and just get that correct. So 5 times 4 is 20, 3 times 5 is 15, add the 2 is 17, and then 2 times 5 is 10, plus the 1 is 11. So in terms of working this out, and we're going to need a bit more space there, so let's get rid of that arrow, we've got 1,170 adults. And to get there, we times by 234. Okay, so we've got quite a bit of information now. We've got a 1,170 adults, and we've got 468 children. And it said, is 60% of the seats filled? And we already worked out that in order to fill that, we needed to fill 1,560 seats. So now we have all this information, and let's get all of this out of the way. We can actually finish this question off, because we can actually just add these two together, and that's going to give us the total amount of people at the cinema. So to finish this off, we'd do 1,170, the total amount of adults, add 468, the total amount of children. That adds up to 1,638, which is greater than 1,560. So where it says it was were there people on more than 60% of the seats, we would say yes, and you could either then write a sentence to say 1,638 is more than 1,560, or you could just say it as an inequality, 1,638 is greater than 1,560. And there we go. And don't forget to write your conclusion here, as it does say that. And don't forget the question does say you must show how you get your answer. So all of that working out is essential. So this question on the screen here, it says only blue vans and white vans are made in a factory. It says the ratio of the number of blue vans to the number of white vans is 4 to 3. And it says for the blue vans, the number of small vans to the number of large vans is 3 to 5. Work out the fraction of the number of vans made in the factory that are blue and large. Okay, so we're looking at these ones that are blue and large. Now, as this sort of question develops and this sort of gets a little bit harder, there's a specific approach that I'm going to take when I'm actually looking at these. And that is I'm going to kind of structure this in the same way that you would structure a probability tree, and looking at this as more along the lines of work out the probability of picking a van that's blue and large out of all of these sort of vans in the factory. And sort of way that I'm going to draw this then is I'm going to draw a bit of a probability tree. So I'm going to start by saying blue to white. Okay, so we've got the vans, they're blue or they're white. Now over here we've got the ratio of blue and white, we've got 4 to 3. Now that's out of 7 in total. So 4 out of the 7 there are blue and 3 out of the 7 there are white. So for the blue here we've got 4 out of 7. And for the white here we've got 3 out of 7. There we go. And then it gives us the next piece of information. Now it only mentions anything to do with the blue vans here, and as these sort of questions develop, we're going to have a look at ones where it mentions something about both branches here. But in this particular question, look, it just says for the blue vans, we've got small and large. So I'm only going to do another branch coming off the blue vans here, and that's going to be our small ones and our large ones. And again, we've got a ratio here, it's 3 to 5, so it's out of 8 in total. So for the small vans there, that's the 3, and that's 3 out of 8. And for the large vans there, it's 5, and again, that's 5 out of 8. Now when it comes to actually working out the fraction here that are blue and large, we treat it in the same way that we do a probability tree. We have a look, okay, we go up the blue branch, and we get 4 out of 7 for the blue. And then we go up the large route or down the large route, depending on how you've drawn it here, and that's 5 out of 8. Okay, and just double check that you've put those in the right place. That's large, 5 out of 8, that's right, so that's blue and large. So all we do normally when we're going along a tree like this is we just multiply those fractions together, and we're not going to do anything different in this question. So all we're going to do is we're going to take that first fraction there for blue, which is 4/7, and I'm going to multiply it by the large fraction there, which is 5/8. There we go. And multiplying fractions is nice and easy. We just times the top and times the bottom. So 4 times 5 is 20. And 7 times 8 on the bottom is 56. There we go, and that's our final answer. 20 out of 56 is our fraction of the vans in the factory here that are blue and large. Okay, so hopefully that makes it quite nice and simple to understand, but essentially we just pair together the two fractions that we're looking at and multiply them together just like we would on a probability tree. Okay, so looking at a money problem. It says here Carla is planning a holiday for 4 people for 7 days. Here are the costs of the holiday for each person. So the travel is £150, the hotel is £50 for each day, and the spending money £250. Work out the total cost of the holiday for 4 people for 7 days. So let's work out each person to start with. Once we've got the cost for one person, we can just times that by 4 as there are 4 people. So we've got the £150 is on the travel, so we know that that's going to be £150. The next one, we've got £50 spending money, £50 for the hotel for each day. So if we're going for 7 days, 50 times 7, well, 5 times 7 is 35. So 50 times 7 would be 350. And of course, you can work that out to the side using column multiplication or whatever method you prefer. And then we've also got the spending money. It doesn't say that's for each day, so we'll assume that that's just the spending money for the whole trip. And then if we add all of those together, that's going to be the total cost per person. So we have 0, 15, so carry the 1, and then 3, 4, 5, 6, 7. So £750 per person. Now, of course, we've got 4 people, so we'd do 4 lots of 750. You could always just add together 4 of them, or just use some multiplication. 4 times 0, 4 times 5 is 20, and 4 times 7 is 28, plus the 2 is 30. So that is £3,000. So the total cost for the holiday for 4 people for 7 days is £3,000, and there's our final answer. Okay, let's have a look at our next question. Okay, so looking at a bit of density without using a calculator. Now, when we've got density in a question, straight away we want to write down our formula, or you could write down a formula triangle. So I'll write down a formula triangle. Density is equal to mass over volume. So if we put that in a formula triangle, we can obviously work out any of them just by covering one of them up. So it says a lead pipe has a volume of 40 and the density of lead is 11.3 grams per centimetre cubed. Now, as soon as you see that, particularly this is a non-calculator question, it's going to put a lot of people off because we've got decimals involved. We know we're going to have to do a multiplication or potentially a division. But it says work out the mass of the lead pipe. So if we cover up the mass on the top there, we know that to work out mass, it's density times volume. So to work this out, we need to do 11.3 and we need to multiply it by 40. Now, that obviously doesn't look very nice, but on its own, that's not a particularly difficult question. All we'd need to do, and there are other methods of going about this, you could do things like multiplying by 4 and adding the 0 on if you're happy to do that. But no matter what the number here, if we just hop the decimal out, if obviously you had a decimal here, we'd have 113 multiplied by 40. We'll work that out, hop the decimal back in, and we've got our answer. So 0 times all of those is going to be 0, so we'll just put 0 for all of that. Then we've got our placeholder because we're moving on to the tens. 4 times 3 is 12, carry the 1. 4 times 1 is 4, plus the 1 is 5, and then 4 times 1 is 4 again. So we have 4,520. Obviously we just need to hop that decimal back in. So if we hop it back in, we get 452.0. It's going to show there that I've put that back in. So our answer would be 452. Now, of course, we're looking at a mass, so we need to give a unit of mass, and we can always find that unit of mass within the question. This particular question gave it us in the density units there. It said grams per centimetre cubed, so that would be 452 grams, and that would be our final answer for that question. So don't be put off by these sorts of questions where they normally appear on a calculator paper. Just follow that same process and remember your written methods. Okay, so solving 4x plus 2 all over 5 equals 6. Now, same process again, it's all locked in by this denominator, which is dividing by 5. So the first thing I'm going to do is times both sides by 5 to remove that divide. Now again, it's not going to change the top there, we're just removing a divide. So 4x plus 2 equals 6 times 5, which is 30. And now, as you can see, it looks very similar to the question that we had before. And we're just going to follow the same approach now to solve it. So it's a plus 2, so we're going to minus 2. So take away 2 from both sides, and we get 4x equals 28. And then, just like before, dividing it by 4, and that gives us x equals 7. There we go, and there's our final answer. For this one, we've got 9x minus 5 equals 3x plus 13. Again here, 3x is the smaller value of x, so I'm going to subtract 3x on both sides of the equation again. Taking away 3x would leave us with 6x over here, minus 5, and that equals positive 13, so I'll just write 13. Again then, moving the numbers to the other side, it's a minus 5, so we're going to have to add 5, and we get 6x equals 18. And this is quite a nice one here, because 6 does go into 18, so when we divide by 6, we get x equals 3. We don't have to worry about any fractions there and simplifying those. Okay, so when looking at recognising graphs, this isn't really one of those ones where you can just teach it on one question. To do this and to know this properly, you need to have looked at straight line graphs, quadratic graphs, reciprocal graphs, cubic graphs as well, and you need to just be able to recognise what they look like when you were learning them, when you were doing them. But for this question here, we'll have a look anyway. So it says our first one here, we're going to match up each of these graphs in the table and put the letter. Now we have two linear graphs, these two here. We've got one with a positive gradient and one with a negative gradient. So we'll start with those two. Now in our equations here, the first one has an x squared, so that is a quadratic graph. The next one is a linear graph, so we'll have a look at that one. The next one's a linear graph as well, and then we have a reciprocal graph down here where there is a division with x. So we're looking at these middle two. Now let's look at the gradients for those. Now the first one, we've got y equals 3 minus 2x, so the gradient of that is negative 2, that number, that coefficient that's stuck on the x. So that one's our negative gradient, so that's going to be graph D, as that's going to be sloping downwards. And our next one has a positive gradient, you can see that's 2x plus 3, so positive 2, a positive gradient, and that'll be graph A. And this is exactly how I'd approach this question anyway. I would pick the one that you're most familiar with. You might disagree and say, actually I knew straight away which one the quadratic was, and that's fine, you could have done that one first, but always work from the one you know to the one you're not so sure on. So for this one here then, the first one, which we've already highlighted, the x squared minus 7 is a quadratic graph. So that is graph B. Quadratic graphs have this U shape, or if it's a negative quadratic, a negative x squared, it has an N shape. But you're probably only going to be looking at these U-shaped graphs anyway. But of course you need to remember that in case there is a negative x squared as well. Now again, you can see that that is correct for this graph because the y-intercept, that number at the end, is negative 7. So that matches up just down there with our negative 7. So that would be fine as well. So we're happy with that. That is graph B. And for our final one, process of elimination, we have our reciprocal graph, and that is graph C, and that is obviously this one just here. So that reciprocal graph has a very unique shape, and obviously you just need to be aware of that when you are dividing by x. You get these reciprocal graphs here which never touch the axes, as when you're dividing by x you can never divide by 0, so it never ends up touching the axes. Okay, so that is recognizing graphs. So this first one says, on the grid, draw the graph of y equals 2x plus 1. Now there's lots of ways of doing this, but essentially it's just about understanding what this actual line equation means here. So we know, hopefully, that all line equations need to be in this form, y equals mx plus c. Okay, so y equals mx plus c. Again, in this line equation, m represents the gradient, which in our line equation here is the number 2, so we have a gradient of 2, and c at the end there represents the y-intercept, which for us here is positive 1, so we've got a y-intercept of positive 1. Now in terms of what that means the graph's going to look like, we know it's going to cross through positive 1 on the y-intercept, which is right here. There we go, I'll try and mark that on, there we go. So we know the line's going to go through this point. And all we have to do is figure out where all the rest of the coordinates are. Now in terms of y equals 2x plus 1, remember x and y relate to the x and y coordinates. So all that this equation actually means is to find the y coordinate, you do 2 times the x coordinate and add 1, or double the x coordinate and add 1. So all we need to do is actually pick some x coordinates. Now if you have a look on the graph, you can see there's lots of x coordinates here. We've got -1, 0, 1, 2, 3 and 4 at the end there. Okay, so all we have to actually do is pick them, double them and add 1, and that'll tell us where the corresponding y coordinate is. And we can do that using a little table. You don't have to use a table, but it just tidy it up a little bit if we just make a little table here. Sometimes you'll be given the table, but it's quite unlikely that you'll be given it. So we've got some x coordinates and we've got some y coordinates we need to find. Now for x, we've got starting at -1, and then it goes 0, and then we've got up to 4, so 1, 2, 3, 4. So if we start with -1, this one here, we need to double that and add 1. I'm going to just sub that into my little equation up there. So y equals 2x plus 1. So it's 2 lots of -1, 2 times -1, and then add 1. And if we double -1, we get -2. Add 1 to that, gives us -1. So our first y coordinate there is -1 as well. So -1, -1. And we can plot that if we want straight away. There it is, -1, -1. Moving on to the next one. What do we have for this next one? We have the x coordinate of 0. So if we just, without doing all the working out for all of these, let's double 0 is 0, and add 1 is 1. So 2 times 0 is 0, add 1 is 1. And if we carry on doing this for the next one, so when x is 1, double 1 is 2, and then add 1 is 3. So double 1 is 2, add 1 is 3. And you can start to see there's a little bit of a pattern emerging. Okay, between all of these points, if you have a look from -1 to 1, that is adding 2. From 1 to 3, that's also adding 2. So actually all we need to actually do is keep adding 2. So add 2 to 3 is 5, add 2 again is 7, and add 2 again is 9. And then we can go ahead and plot as many of these as we can. Obviously we can't do them all here because the graph's not big enough. But for the next one, let's have a look. 1 to 3 is there, and 2 and 5 is there. Okay, so they're all the points we can plot. We could actually only plot it up to this point here. But once we've done that, all you need to do is grab a pencil, grab a ruler, and join it up nice and straight all the way through the graph, unless it states otherwise. So with your ruler, nice straight line going all the way through and extending it up to the edge of the graph there. There you go, and that is your line. And it's always good practice just to label it. You don't have to, okay, but you could just label that as the line y equals 2x plus 1. It just helps if there are multiple graphs or multiple lines on the graph, but you don't have to label it unless you're asked to. Okay, but there you go, y equals 2x plus 1. There are other ways of drawing this, and it just comes to having an understanding of the equation there. So we already talked about one of them, the fact that it starts on the y-intercept at plus 1. And then the fact that it has a gradient of 2 just means that for every step across from a point on the line, so if we look at this as, I know it's 2 squares there, you've got to be careful of the scale, but that's 1 across, going from 0 to 1, and if you have a look, it goes up from 1 to 3. There you go, so it has a rise there of going up 2 for every 1. And you can always draw this in, it's a way of understanding it as well, so it's 2 there, and 1 here. Every 1 across it goes up 2, and that's what a gradient of 2 actually means. It means for every 1 step across it goes up 2 steps, even though the scale's slightly different here. It's 1 in terms of the numbers across and 2 in terms of the numbers going up, and that is what a gradient of 2 actually represents. But its best bet is just to draw the little table out and then get all your numbers nice and neatly drawn in. Okay, so when looking at intersecting graphs, we're going to have a look at this particular one. This is always one that looks way more complicated than it should. So it says here, use the graph to solve these simultaneous equations. When you're solving simultaneous equations, normally you're finding that x and y value, and that x and y value relate to the coordinate where they cross over. And you can see on this graph here, we can actually see that coordinate just there. So normally, when we're looking at simultaneous equations, like this one here, we try and make the coefficients of x or y the same, same sign subtract, different signs add, or whatever process you use to do that. Now this particular one has already shown us the graph, so we don't have to draw them, we don't have to do it algebraically. All we literally have to do is read that coordinate. So we'll go down, we'll read our x coordinate first, so x equals -2, and then we'll read the y coordinate, so go along, and we get y equals 4. And there we go, and that is using the graph to solve it. Of course, you might be asked to write down the coordinates of the solutions, in which case you would write it as -2, 4. Just make sure you read the question. But if it says find the solutions, we would write x equals and y equals. Okay, of course, you could also have to draw linear graphs and actually do these yourself, but this is just intercepting graphs and understanding where the lines cross over is that solution. Okay, so in this question we are given a line already drawn on a graph, and it says write down the equation of the line. Now we know already that what the equation of a line is going to look like. It's in this format, y equals mx plus c. Again, that c being the y-intercept. Now we can see the y-intercept on the graph, it's over here, 5. So for starters, I can actually just draw that straight in. We can say c equals 5, and we can just put that in our line equation, so y equals mx plus 5. All we need to figure out is what the gradient is. Now if we have a look at this question, we've got to find some coordinates that we can actually see. So here's another coordinate that's on the line, 1, 3. Now if I want to find the gradient between these 2 points, all I have to do is draw a little right angled triangle in. So I can go across or down from this red point, but if I go across and then down, I'm just going to say how big the movement is there. So that's a movement of 1 there. And then that's going down 2, so I'm going to say that that's -2. Now the equation to get the gradient, there's 2 different ways that you can look at it. You can have a look at it, and it's just use this little triangle. It means the change in, so it's the change in the y coordinate over the change in the x coordinate, and it's sometimes referred to as rise over run. Okay, so you might know one of these 2, but change in y over change in x, or rise over run. Now in this case, look, the change in the y coordinate is this movement here going down, it's -2. So that'll be on the top of my little fraction here, -2. And the run, or the change in x, is on the bottom there, is the 1 going across. So it's -2 over 1. And -2 divided by 1 is -2. Okay, so my gradient here is -2. So it's obviously sloping downwards, which is why it's got a negative gradient, but that's what our gradient actually is for this question here. So all I've got to do is put -2 in place of m, and we get y equals -2x plus 5. Obviously, thinking about that last question that we looked at, you could actually write that as 5 minus 2x, but you can write it in either way, it's absolutely fine to do so. Just a little side note, you can actually do these triangles as big as you want. If I picked some different coordinates, let's have a look, that one there, and this one here, for example, and if I was to go down instead and make a big triangle like this, let's have a look. My run there is 4, and my rise goes from 7 down to -1, which is a movement of -8. And if I did rise over run for this one, or the change in y over change in x, it would be -8 over 4, and -8 divided by 4 is -2. So you can do this however you like, okay, because it's a straight line, it doesn't actually matter where you do the gradient from, it's just you just need to draw it in, just read those numbers very, very carefully so you can get the correct gradient there. Okay, so using some formulae. So this one here says make Q the subject of, and then we have a formula to rearrange. So when making Q the subject, we need to get rid of that constant to start with, so we're going to get rid of this +7. We're going to do that by minusing 7 to the other side. So our first step would say P minus 7 is equal to 6q. Always write out your steps. Now we want q to be the subject, not 6q, so we're going to have to divide by 6 to get that 6 unstuck there from the q. So if we divide by 6, we'd have p minus 7 all divided by 6, and always write it as a fraction. We don't want any multiplication or division symbols in a formula, and that is going to be equal to q. And if you want, you can write that the other way around. You can write q is equal to p minus 7 over 6, but it's fine to leave that equals q on the right hand side. Now we've got part B. It says part B, using your answer to part A, find the value of q when p is equal to -11. So we've already got q is equal to, and then p minus 7 over 6. So all we need to do is substitute p is equal to -11 into our rearranged formula. So if we put that in, we've got -11, take away 7, and all divided by 6 will be equal to q. Well, let's simplify the top. Negative 7 and negative 11, let's say that the right way around, negative 11 take away 7 would be equal to negative 18. And we're going to divide that by 6. 18 divided by 6 is 3, so negative 18 divided by 6 is going to be equal to negative 3. So Q will equal negative 3. And that'll be our final answer there, substituting that in. So it says find the 20th term in the sequence, and it starts to give us the start of a sequence. And obviously what we could do is just see what it's going up by and keep writing it, but if we're trying to find the 50th or the 100th term, it's not a very efficient way of us doing that. So we're going to actually have a look at how we can use the nth term to find the answer to this. So first of all, we're going to actually find the nth term of this sequence. So to start with, we note that it goes up in threes. So the start of our nth term is going to be 3n, which means it's related to the 3 times table. And obviously using our little trick, we can go backwards. So take away 3, and that gives us positive 1 here. So it's 3n plus 1. Now thinking about what that means, and I've mentioned it in the previous video, and that means the 3 times table but with 1 added on. Now if we want to find the 20th term in the sequence, all we actually really have to do is sub 20 into this expression here. So n is going to become 20, or 3 times 20, it's obviously the 20th term in the 3 times table is 3 times 20. So if we do 3 times 20, so I'm going to sub that in, 3 lots of 20, but then we just need to add 1 to that. So 3 lots of 20 is 60. And add 1 to that gives us 61. And that's how we can find numbers in a sequence quite quickly there. Okay, so find the nth term, sub the number in, and then obviously just write down what that number in the sequence is. As a sequence has an nth term of 2n squared plus 5, find the 10th term in the sequence. So obviously we've got a different nth term here. This is a quadratic sequence, but we're going to approach it in exactly the same way. Now it does have a little n squared there, but it's already given us the nth term, so we've not had to find the nth term of this sequence, it's just been given to us, and it does look a little bit different to the previous two, but we're just going to apply it in the same way. So if we want to find the 10th term, we just need to sub 10 in. So if we sub 10 in, we've got 2 lots of 10 squared, n squared, 10 squared, and then add 5. Okay, so obviously remembering your order of operations here, you've got to work out the powers first, which is why I've put the 10 squared in the brackets, not to forget to work that out first. So 10 squared is 100. I'm just going to write that there, 10 squared is 100. So 2 times 100, working out this bit, would be 200, and then add 5 would give us 205. There you go. So a little bit of rules on substitution there. Obviously, don't forget to check out the video on substitution if that's thrown you at all, but just being careful to sub that number in. So we've sub 10 in place of the n, that's n squared, so 10 squared was 100, 2 lots of that is 200, and then add 5 at the end for 205. Okay, so this question says, is the number 51 in this sequence? Now again, we could keep writing and see if 51 appears, but we can actually just use the nth term again to actually figure out a question like this. Is the number 51 in the sequence? So if we find the nth term, okay, it goes up in 4s, so it's 4n, and then back 4 again, gets us minus 1, so 4n minus 1. Now there's our nth term. What we could do is we could just sub numbers in, see if we get 51, you know, sub 10 in, that'd be 40, take away 1 is 39, and just keep trialing and erroring it. But actually we can take a quick approach again. Now if we want to know if 51's ever in the sequence, we want to know, is there a number that I can sub into there that ever equals 51? And I can make that statement just by writing an equation. So I can just say, well, does 4n minus 1, does that ever equal 51? Okay, so does 4n minus 1 equal 51? And if we go about trying to solve this, let's see what we get. So if we add 1 to both sides, we get 4n equals 52. And then solving this just like a normal equation, divide by 4. So divide by 4, and we get n equals, and 52 divided by 4 is 13. There we go. So we get n equals 13. Now what we found out there is that if we sub the number 13 in place of n, that would give us 52. And you can go back and check it. 4 times 13 gives us 52. And then when you take away 1, you get the 51. So there we go. When we sub 13 in, we do get 51. So yes, we would say 51 is in the sequence, and we could even say it's the 13th term in the sequence there. Okay, so looking at some parts of circles. It says here, on the diagram below, draw a chord of the circle. Now a chord can be drawn in lots of different places, but we've got lots of different ways of drawing a chord as well, 2 specifically. Now you could draw a diameter Okay, a diameter is a special name for a chord that passes through the centre. So you wouldn't be wrong to draw the diameter in. And of course, by doing that, I've already described to you what the diameter looks like. But a chord can be drawn anywhere as long as it touches 2 points on the circumference, and it's just a straight line. So we could draw it anywhere, it doesn't need to pass through the centre, and that right there would be a chord. You could also potentially be asked to draw something like a segment, and maybe it would ask you to shade that in. If you asked to draw a segment, that would just be this bit just here. You could shade that in as well. Obviously, if you were asked to draw a segment. As well as that, you could be asked to draw something like a sector. So you could use the radius and another radius to form a sector. So that's another piece that you could be asked to do as well. But of course, you are only asked to draw a chord. And our next one here asks you to draw a tangent. So a tangent is a straight line that touches the outside of the circle on the circumference at 1 point and then keeps on going. So you've got to draw this nice and carefully. But there we go, that would be a tangent. So lots of different things that you could be asked to draw. We talked about the diameter, the radius, a segment, a sector, the chord, the diameter, obviously could be a chord as well, and now the tangent. So lots of different things that you could draw on a circle, but there we go. There are our 2 questions. Now for this question here, we've broken it up into 2 parts, and we're going to do them both on this one grid. And as you can see on the grid, we've got a triangle there drawn at this position here, obviously over in the positive section. Now when we translate a shape, what's going to happen is this triangle is going to move somewhere else. Now it doesn't necessarily have to go into any of the other sections, but it's going to move somewhere within this grid. So if we have a look at this first one to start with, it says translate the triangle by the vector, and then we have -4 on the top and 3 on the bottom. Now, if you don't have a very good understanding of vectors, there is a full video that I have done on column vectors, which I'll link in the description for you to have a go at. But in regards to this one, we're going to go through it relatively quickly. So that number on the top there represents going left or right. So a positive number moves it right, and if we have a look on the grid, look, the positive numbers go to the right and the negative numbers go to the left. So a positive number on the top indicates moving right and a negative number indicates moving left. And that goes for the same on the bottom, except the bottom number there is representing moving up and down. So again, positive numbers move it up and negative numbers move it down. Now the way to go about doing these is just to pick one of the corners or one of the vertices on the shape. I'm going to pick that top one there. I'm going to move that point 4 to the left, as we have -4 on the top, and I'm going to move it by 3 up. So let's move that. So we go 1, 2, 3, 4 to the left, and then 1, 2, 3 up, and that's going to finish off just there. Now, I would encourage you to draw these lines in, although you certainly don't have to. Obviously, if you do draw them in, just do them nice and lightly in pencil. Now I'm going to get rid of that, and we're going to draw it in from that point. Now just be careful, obviously, we're going to redraw it in from the point that we actually moved, so that top position of the triangle. So from there we need to go down by 2, again just keep looking at the triangle, it goes across by 1, so across 1, and then join it up. And obviously if the question says to label it with a letter or to shade it in or something like that, then obviously just make sure you do that as well. Now let's look at the next one. The next one's slightly different because it's going to move it slightly differently, because this time our vector says to move it 2 on the top and -4 on the bottom. So 2 on the top would indicate a movement of 2 to the right, and -4 on the bottom is 4 down. I'm going to pick a different corner this time. Let's go for this bottom right one. So 2 to the right, that would be 1, 2, and then 4 down, so 1, 2, 3, 4. There we go, and let's just put a little cross there. And obviously this time then we're going to be drawing this particular triangle in from that bottom right corner. So we need to draw the base in to start with, up 2 for that triangle, and again joining it up, and again doing that nice and neatly with a pencil and a ruler ideally. Okay, so we've got a question here. It says, describe fully the single transformation that maps shape P onto shape Q. So we're going to go from the shape on the left to the shape on the right. Now the process is pretty much the same here, we just need to figure out how far it's actually moved. So let's match up some similar corners. So we've got this one on the top right, and we'll match it up to that one there. Now let's have a look how we get there. So from P to Q, so we'd have to go right, 1, 2, 3, so that's 3 to the right, and then 1 down. There we go, so 3 to the right and 1 down, and we could even put a -1 there, as we know that 1 down is going to be a minus. So in order to draw or write out our description here, we are going to have to state what kind of transformation it is. So we know that that is a translation. So we can say it's a translation, or we can also say it's been translated. So I'm going to write a translation. There we go, so a translation. And then in order to describe the movement, we give the vector. So I'm going to say a translation, I'm going to say by the vector, or you could say using the vector or anything along those lines, and then we just need to write that vector in our bracket. So that's 3 to the right, so that's positive 3 on the top, and then 1 down, so that's negative 1 on the bottom. And there we go, that'll be 4 marks for us on that question. Alternatively with this question, obviously, you could be asked how to get from Q to P. And that would have been slightly different because actually to get from Q to P, we would have gone 3 to the left and we'd have gone 1 up. So it would have been pretty much the same vector, but the symbols in front of those numbers would be different. We'd have -3 and we'd have +1 if we were going in the other direction. So there we go, that's how we're going to describe a translation. It's very important that you include all of these words. You do need to say the word translation. The word moved is not going to get you the marks for this because that's not the transformation. The transformation is called a translation. And we also do need to give that vector, and ideally stating that by the vector and actually then giving it. Okay, so working out the perimeter of a circle sector. Now it says A is the shape of a quarter circle of radius 15, and we can see that. Work out an estimate for the perimeter of shape A. Now, quite a nasty one. So if we're going to start working this out, for starters, we've got the word estimate. So we're going to use pi is equal to 3. So pi is equal to 3 for this particular question. Now when we're working out the circumference, that's going to be part of the perimeter. So this little arc here, which is part of the circumference, as we just said, is one of the numbers that we need. So we need to think about our circumference formula. So the circumference is equal to pi times diameter. So for this particular circle, the radius is 15, so the diameter will equal 30. So to work out the full circumference, we would do the circumference is equal to pi is 3 times 30. So the circumference is equal to 90 centimetres. Now this is a quarter circle, so for just the length of that arc there, we're going to want to divide that by 4. So 90 divided by 4. Now you could write that as a fraction, 90 over 4, or you could start to simplify it, something like that. But if we were to write 90 divided by 4, that would come out as, well, we could halve it, we could get 45 divided by 2, and that is 22.5 centimetres. Okay, so not very nice there to get that particular length, but that there is 22.5 centimetres. Now to get the perimeter, we just need to add them all up. So we have the 15, we've got another 15 here for the radius, and then we just need to add them all together. Of course it did say to estimate, so we could have estimated 90 divided by 4. You could have rounded that up maybe, or I mean you'd probably leave that as 90, but you could have maybe rounded 22.5 to 20, but I think that wasn't too bad there, dividing 90 by 4, so we probably have a range of answers for this if it was an actual estimate question, but we'll add these all together. You've got 15 plus 15 plus 22.5, and if we add those together, that's 30 plus 22.5, which is 52.5 centimetres, and that'd be our final answer just there. So obviously when it comes to circle sectors or looking at circles in general on a non-calculator paper, there's 2 different types of questions that you could have. You could have one like this where we're doing an estimate, or you could be asked to write things in terms of pi. So if we just think about another type of question that you could have here, for example, if we were asked to work out the area in terms of pi, what would we do? I'll leave that last line of working out there that we did for this question, but if we were to work out the area in terms of pi, what would we do? Now we would still use our area formula, so area is equal to pi r squared, and for this one here, obviously I'm making this up, so we'll have to think about the numbers as we go along, and then we'll have to divide our answer by 4. So we'll work out the area as if it was a full circle, so we would do pi times 15 squared. Now pi times 15 squared you'd have to work out to the side, that's 225, so we'd write the answer as 225 lots of pi. That's what doing it in terms of pi means, we just don't press times pi. So we've got 225, which would be the area of the full circle, but of course this is a quarter circle, so we'd have to divide that by 4, and because we are leaving it in terms of pi, and because 225 doesn't divide perfectly by 4, we'll just write it as a fraction over 4. Of course that might divide by 4, you know, if the number squared, for example, if it was 10 squared, and that was divided by 4. 100 divides by 4 quite nicely, so you could have 100 divided by 4, which would give you 25 pi. But this one in particular didn't divide by 4, so it'd be fine to leave it as a fraction. Of course, that's not what this particular question asks, but just a thought there if you had to write something in terms of pi as well. So it says that A to B to C is a straight line. So that tells us that these two angles next to each other have to add up to 180. So that's something we might use at some point. But it says work out the size of angle, and it gives us something different here. It says angle BDC. So to find angle BDC, you go from point B to point D, and then down to point C. And you can see that by drawing that, it has created this angle just here. So that is the angle BDC, and that is the one we're actually going to be looking for. So again, you can obviously trace your finger over the shape to find that at any point. So let's think about that. We've got a triangle on the right there, this one just here, which is a scalene triangle. There are no lines on that particular one. There is a line just here, obviously because this triangle on the left is an isosceles, but that line there doesn't necessarily relate to the triangle on the right. So the triangle on the right is a scalene triangle. All the angles will be different or could be different. And on the left here, we've got an isosceles. So because we have that top angle in the isosceles, we can definitely work out these two base angles. Again, just finding the ones underneath those two little lines. So at the moment, there's a top angle of 70. So if we do 180, take away 70, it's going to tell us what's left to be split between the two base angles. And that is adding up to 110. So if we divide that by 2, that will split it into our base angles, and 110 divided by 2 is 55 degrees. So both those base angles are 55. Now that's going to allow us to move into the other shape. As we mentioned at the start, these two angles just here are going to add up to 180. So to find this angle just next to the 55, we would do 180 and take away 55. And that gives us an angle of, and again you can do your working out for this, but that gives us an angle of 125 degrees. So this one here is 125. And now you can see we have enough information on this right hand triangle to find our missing angle, because we now have two of the other angles. So if we add those two together, we've got 125 and 29. And if we add them up, that adds up to 14, 5, and 1, so 154 degrees, and we want to take that away from 180. So to finish this off, our final bit of working out, we'll do 180, take away 154, and again, if you can do these mentally, that's absolutely fine, but we'll just do our written method for the purpose of this video. 10 take away 4 is 6, 7 take away 5 is 2, and 1 take away 1 is 0, so that final angle there is 26 degrees, and that is the final answer for our question, because there we have found angle BDC. Okay, so here is our next question. It says here is a scale drawing of a garden. It says we need to plant a tree 5 meters from point C, nearer to AB than AD, and less than 3 meters from DC. Shade the region where we can plant the tree. So this time we've got 3 things to be aware of, and also we are going to shade a region rather than a point. Now if you do want to draw this out and you want to replicate it in the same size, I could just measure this rectangle for you, and as you can see it's 8.5 centimeters down, and if we want to go across, the rectangle is going to be, let's have a look, around about 13 centimeters across. So again, you don't have to draw this, but if you did want to follow along by drawing it, then you can absolutely do so. So we'll start with the first bit of information here, where it says we need to plant a tree 5 meters from point C. So if we're going to go from point C, then again we're going to draw a circle around point C. But it does say it wants it to be 5 meters. So we need to have a look at our scale, and as you can see down the bottom it says the scale is 1 centimeter is equal to 1 meter. So for 5 meters that is going to be 5 centimeters. So we just want to get our ruler and measure out our compass. So again, putting the compass point down at the bottom of the ruler and measuring out where 5 centimeters is. So 5 centimeters is only that far this time. So we'll put our compass point onto C and we'll draw a nice circular arc that shows where it has to go. So there we go, that is going to be 5 meters from point C. So there we go, that's our first part. It now tells us that it has to be nearer to AB than to AD. So A to B is the line that goes across the top of the rectangle from A to B, and A to D is the line that goes downwards from A, obviously from A to D. So in order to do that, we need to do an angle bisector, because we're going to want to find the points that are closer to AB than to AD. So we need to bisect the angle in half so that we can see all of those points on that half. Now obviously this is a rectangle and not a square, so you wouldn't want to just join the point A to C because that's not going to be a perfect angle bisector. So obviously watching the video on angle bisectors would be very helpful for this, but if you haven't watched the video on angle bisectors, I'll just explain it. So we go up to point A and we're going to put our compass on point A. And there are two ways to draw an angle bisector. I do it in one particular way, so I'm going to follow the process that I did on my video. So all we do is we take our compass and we're going to draw a nice arc that joins up the two lines, and we're going to draw a nice little arc like that, and then we just extend our compass slightly further and we're going to draw another arc, and there we go. And that's all we need our compass for, so we can put our compass out of the way now, as that's enough for us to draw our angle bisector. So if we move this out of the way, and we'll actually now join these up. So what we do at this point, so we do like what's called, well, what I call a crisscross. So I take the lower point of the first arc and join it to the higher point of the second arc, and then again the other lower point on the first arc and join it to the other higher point on the second arc. And where those lines cross over, that is going to be where our angle bisector needs to go from. So we go back to point A, and we're going to bisect the angle, and I'm going to extend that all the way to the end of the shape. And there we go, that has now split my rectangle into two halves in terms of closer to AB and closer to AD. Obviously we need to be closer to AB, so we're going to be above that line, obviously closer to the B point on the top right of the rectangle. Now we've got one more bit of information that we need to do, and that says that it needs to be less than 3 meters from DC. So in order to get less than 3 centimeters or meters from DC, we actually want to measure 3 centimeters above the line DC. I've said 3 centimeters because 3 meters would be 3 centimeters according to our scale. So if we put the ruler down the bottom of this side to start with, you can see where 3 centimeters is. And we just need to mark that up. And we're just going to put a little line here where 3 centimeters is, and then we're going to do it on the other side. So going over to the other side, and again just marking that 3 centimeters so that we know where 3 centimeters up is on both sides. Now you would want to take your ruler and join those up nice and carefully, and we have a nice straight line. And again, mine's not going to be absolutely perfect. I probably could have done that a little bit better. So I'd go again. Oh dear, that's definitely not better. There we go, that's looking perfect. So there we go, there is our line, and above that is going to be greater than 3 meters from DC, and below that is going to be less than 3 meters from DC. So now we actually want to go about shading this position on the map here, or the scale drawing. So we need to plant it 5 meters from point C, and we need it to be nearer to AB than AD, and it has to be less than 3 meters from DC. So it has to be below that pink line, and it has to be closer to AB than AD. So if we think about where this is going to be, we know that it can't be above the line, so it can't be here, it can't be over here, it can't be over here, but it has to be below that. Now we know that it also can't be closer to AD, so any of these regions here below the blue line it can't be. It can't be this little one down here either. That only leaves us with 2. So we need to plant a tree 5 meters from point C. So if it has to be 5 meters from point C for whatever reason that it can't be close to point C, it will have to be this little region here just in the middle. Otherwise it would be closer than 5 meters from point C, and it has to be at least 5 meters from point C. So that's the only region that it can be based on that bit of information, and that would be the final answer to that question. But as you can see, a question like this is pretty difficult because you've got all these construction lines all over the place, and you've got all these different bits of information. So you just need to go through them slowly, and crossing off some of the regions can be quite helpful. So obviously we've picked the easiest one to start with, which was that it had to be less than 3 meters from DC or below that pink line, which allowed us to cross off a lot of those regions. And then obviously the fact that it had to be closer to AB than AD allowed us to cross off the ones down the bottom below the blue line, and that only left us with 2 then. So we just had to think about that first piece of information, which said that we need to plant it 5 meters from point C, which just meant that it had to be above or greater than that first arc that we drew when we drew a circle around C. So this question is slightly different, look, as we don't have an actual shape. We've got 3 points on a map. So we have the points A, B and C, and they kind of form this triangular shape. Now if you want to draw out again a sketch of this, again just try and draw this out to the same sort of size that it would be on a computer screen, but otherwise don't worry too much about actually getting this the exact same size. It says point T is 250 meters from point A, and then it says point T is equidistant from points B and point C. On the map, show one of the possible positions for this point. So we've got 2 bits of information. It's got to be 250 meters from point A. So if we read the scale there, it says that 1 centimeter is equal to 100 meters. So this is going to be between 2 and 3 centimeters. It's going to be 2.5. Again, you could divide 250 meters by 100, and that would give you the 2.5 centimeters that it has to be from point A. So if we start by drawing that, we're going to get our compass again, put it at the bottom of our ruler, measure out 2.5 centimeters. And then we're going to draw a nice circle around A, and that will show us all of the points that are within that 250 meters. So if we put it around that point, draw a nice circle around A, now we know all of the positions there that are 250 meters from point A. So it has to be somewhere within this circle, or on the outskirt of the circle on the circumference, and that all of those points around that circle are 250 meters from A. So for the second piece of information, it says that point T is equidistant from points B and C. So to get it to be equal distances from points B and C, we're going to have to draw a perpendicular bisector of B and C. So we're just going to have to join them up to form the line which we could call BC, and now we're going to want to draw a perpendicular bisector. So again, we'll get our compass, we'll put it on point C, we'll extend it past halfway, and we're going to draw a nice arc all the way round. And then we're going to move that onto point B without changing the size of the compass, and again drawing a nice arc there so that we can draw our perpendicular bisector. So we can move all of this out of the way, and now we're going to want to draw our line. So again, if I start on the right hand side so that I can extend it over past the circle, then you can see that there are 2 points where it crosses the circumference of the circle. So we want to obviously only label one of those points. As it says, show one of the possible positions for T, and those 2 positions where our perpendicular bisector intersects the circle are both of our points. So obviously we would only mark one of these, but if we mark them both, we could choose either this position here, or we could choose this position here. Of course, being very careful because it does say to mark one of the possible positions. So we would only mark one of those, and that would be the answer to this question. Okay, so looking at a probability problem. It says that there are 9 green beads and 11 blue beads in a box. Jim adds 10 more beads to this box. He's going to take at random a bead from the now 30 beads in the box, and the probability that he will take a green bead is 2/5. How many green beads did Jim add to the box? Well, if he adds more beads into the box, and now it's out of 30, well, what would this fraction be out of 30? So let's figure that out. Well, if we want 30 on the bottom, we'd have to multiply the 5 by 6, and we'd do the same to the top. So 2 times 6 would equal 12. So out of the 30 beads, there must be 12 green beads. And pretty much that has already solved the problem just by turning that denominator into the new amount of beads in this box. So if we look at this, we've currently got 9 green beads. We know that it has to go to 12. So we must have added 3 additional green beads into the box. Okay, so we'll just double check our thought process there. So it's out of 30, our probability was out of 5. So to make that out of 30, we've multiplied by 6. So the numerator goes to 12. There were 9 green beads. That's gone up to 12. So that's an extra 3 beads. So 3 green beads. Okay. And there we go. There are obviously other ways of working that out as well. Like you could add an amount, basically trial and error. You could add 1 bead in, 1 green bead in, see if that simplifies down to 2/5 if the rest were blue. If that doesn't work, add 2 green beads in, add the rest to blue, see if it simplifies. But I think this was definitely the fastest way here, just looking at that denominator, making sure it matched how many beads were going to be in the box in total. So there we go, there's a little probability problem. Now you obviously need to be aware of how to use Venn diagrams as well when we are looking at inputting numbers from a given set of lists, and I'll link that in the description for you to check out as well, but in this one we're going to have a look at these more problem solving style based questions. So the one that you can see on the screen, we're going to have a little read through. It says 50 students were asked if they have a cat or a dog. 22 have a cat, 18 have a dog, 8 have both a cat and a dog. Use this information to complete the Venn diagram. Now sometimes you'll be given a Venn diagram, sometimes you'll have to draw it for yourself. For the purpose of these videos I've put them all in, but just be aware that you could have to draw them. So obviously if we have a Venn diagram we need to label it up to start with. Now this question mentions cat first, so I'm going to put the right as the other one and the left one as the one that's mentioned first. So I'm going to put cat here and I'm going to put dog over there. Again, it doesn't matter what order you put it in, just make sure that it's clearly labelled. So looking at this question, it first says to us that 22 have a cat. Now the problem with the Venn diagram is we can't just put 22 in this cat section because there are some people that also have a dog, so some of them are going to have to go in there. So don't just put the first number in straight away, instead let's read through the entire question and see what information we have been given that could be put straight in. So it then says that 18 have a dog. Again, we can't put that straight in. If it did want us to put it straight in, it would say only before the word dog, so it would say 18 people have only a dog. But there we go, we can't put that in. So moving on to the next bit, it says 8 have both a cat and a dog. So that bit of information can go in because we know that 8 that have a cat and a dog would have to go into the centre. So straight away in the middle, we can put that 8 have both. It doesn't tell us how many have neither, so that is the unknown piece of information we're going to have to work out. Now we can move back to that first line as it says that 22 have a cat. Now you can already see that part of those 22 over here, we've got 8 that have a cat and a dog, but those 8 people are included in the 22 people that have a cat. So to work out how many people have only a cat, we would have to take away the 8 in the middle from the 22. So do your working out to the side, I would write 22 take away 8, and that is going to give us a total of 14 that have a cat. And now you can check because these two numbers should add up to 22. So 14 and 8, do they add up to 22? The answer is yes, so we've got that correct. We can then move on to the 18 that have a dog. Now of course we've still got the 8 in the middle, so we would take away the 8 in the middle that have both away from the 18, and that leaves us with a total of 10. So 10 people have only a dog. And now we've got quite a lot of information there, but we need to figure out what goes on the outside. Now if we add all of those up, so 14 plus the 8 plus the 10, that adds up to 32. So we have 32 people. Yeah, it does add up to 32, yeah. We've got 32 people, so we need to figure out what goes on the outside. So at the moment we've got 32. To make that up to 50, we would have an additional 18 people that would go on the outside that have neither a cat nor a dog. Okay, so that's one type of question that you can have where we've been told what goes in the middle in the crossover section, in the intersection. So let's have a look at one that's slightly different. And to be honest, before we start, we need to just have a look at this little symbol here. This just means the universal set. It just means all the numbers that are going to go inside this Venn diagram somewhere in there. And in that, it says all the odd numbers less than 30. So it might just give you the list of numbers. If it doesn't, it's probably best just to write them all out. And there's quite a lot of odd numbers between 1 and 30, less than 30. So I'm not going to write them all out, but you could just go ahead and write them all out. 1, 3, in fact, let's just write them out. 1, 3, 5, 7, 9, 11, 13, 15, 17, 19, 21, and the rest. Now these are all the numbers that are going to go in the Venn diagram, and they're only going to go in there once. Okay, so there's not going to be any repeats of these numbers, but they are all going to go in the Venn diagram. Now it says set A has got these numbers and set B has got these numbers. Now if it doesn't label the circles in the Venn diagram, just label them yourself. So we'll call this A and this one B. So having a look, now the first thing we want to identify is what can go in the crossover, the intersection there. So if we have a look in A and B, there is a 5 in both. So let's cross off the 5 and let's put that into the Venn diagram. And I'm also going to cross that off my main list up here as well, cross that off, so we're not going to put it in twice. Let's have a look, there's also 15 in both, so let's cross that off and we'll put that in the middle as well. And then we'll cross that off the main list. So these are all the numbers that we've got left to put in a Venn diagram. There's none that are in A and B anymore, so all those numbers are in set A. I'm just going to put them in the A circle, so 9, 17, 21 and 29. We'll cross those all off and cross them off the main list, so 9, 17, 21 and 29. There we go, they're gone. And then 25 in B as well, so we'll put that one in there. Again, crossing it off both lists. So in terms of the numbers we have left, we've got the 1, we've got the 3, and I'm not going to circle them all, I'm just going to start putting them in because the others are crossed off. We've got 7, 11, 13, 19, 23 and 27, there we go, and that is our completed Venn diagram. Now we could be asked any sort of question on probability here, but I've put a little selection in down the bottom. It says a number is chosen at random, find the probability that is in set, and then we've got 3 questions to have a look at. So we've got 2 symbols that we need to know here. We've got the U, which is the union, and there we go, the union, we'll talk about that in a sec, and we've got the N, which is the intersection. There we go. And these little symbols can be replaced with some words if it helps. So the U for union, I replace with the word or, and the N for the intersection, I replace with the word and. And I quite like replacing it with the word and because the middle letter in and is N. So I always tend to remember that the intersection there, the N is and. So let's have a look. The first one is U. So we've got A or B. So the numbers that are in A or B. And it is a probability, so we'll talk about writing it as a probability in a sec. But if we have a look at the numbers that are in A or B, well, we've got the 9, the 17, the 21, the 29, which is in A. We've got the 25, which is in B. And then we've also got the 5 and the 15, which is in A and B. So just because that's in both doesn't mean it's not in A or B. So in fact, finding the numbers that are in A or B is all of these numbers within the Venn diagram, okay? So they are all the numbers that are within the Venn diagram then. If we count them up, there's 1, 2, 3, 4, 5, 6, 7 numbers there. I'm going to get rid of that highlighter there, but we've got 7 numbers. So let's write that down. We've got 7 numbers that are in A or B out of a total. And again, you can count them all from the Venn diagram or from that list that I did at the top, but all the odd numbers between 1 and 30. There are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 numbers. There you go. So it's 7 out of 15. So that word union, if you think about that as like the United Kingdom, the union is the collection of all the countries there, and it's the same for the Venn diagram. It's the collection of everything within that sort of that land there. If you kind of imagine it like a country, you've got the collection of all the numbers. So you've got 7 over 15, and that is the union of A and B. Now if we have a look at the next one, so B, we've got A, N, B, or the intersection of A and B, which again can be replaced with the word and. So the numbers that are in A and B, well, there are only those 2 numbers there that are in both A and B, the 5 and the 15. So that there is the intersection, the numbers that are in A and B. And if we write down the probability of that, that's 2 numbers out of, again, 15 numbers. There you go, so there's our 2 options there for the union or the intersection. I've also included this extra one here as well for C, which is A dash. Now if there's a dash with a letter, it means not in A. So all that little dash means is any of the numbers that are not in A. Now if you have a look at the numbers that are not in A, well, we've got the 25, which is in B, that's not in A. We've got all these numbers around the outside that are not in A, but none of the other numbers. So we've got the numbers which are just in A, the 9, the 17, the 21, the 29, and we've also got the numbers that are in A and B, the 5 and the 15, but they are also in A, so we can't have those ones. So we're just looking at the numbers that are in B and the numbers on the outside. So we've got 1 number in B, and 1, 2, 3, 4, 5, 6, 7, 8 numbers there in green around the outside. 8 plus 1 is 9, so there are 9 numbers that are not in A, and again that's out of 15, writing it as a probability. So it says some people went on an activity course and each student had to choose one activity from art, drama or music, and then it starts to give us all this information that I'm going to read through in a little bit. It says one of the students is chosen at random, write down the probability that it is a boy that chose music, and we'll discuss that a little bit more at the end. Now when it comes to this sort of question here, and I said already we're going to have a look at two-way tables, we need to get this information organised, okay? There's so much writing there, there's so much going on, and a two-way table in this circumstance here is going to make this a lot more, well, add a lot more clarity to this question. So if we have a look, okay, it says that they choose from art, drama or music, and then later on it goes to talk about whether they are boys or girls and what they chose. So when it comes to this type of question, all we need to do is draw a little table. I'm going to try and draw one as best as I can here. There we go. So I'm going to have a few rows there so that I can have boys, which I'm just going to label as B, girls, which I can label as G, and I'm going to put a total down here as well. There we go. And then obviously they chose from 3 different activities. So we've got art, which I'll put first, we've got drama, there we go, and we've got music. There we are. So there, are my columns. Okay, so start putting this information in, and again, I'm going to put a total column at the end there. Right, there we go, just extend that a little bit. Right, okay, so we can start putting all these pieces in the right boxes, okay, and obviously your table is just a way of organising it, so you don't have to worry about whether you put the boys and girls down the left or whether you put art, drama and music down the left there. Okay, you can organise it however you like. But we've got 41 students in total, it says, so I'm just going to go through this line by line and see what I can put in. So there are 41 students, so we'll stick that in, that's 41 in total of the boys and girls in the bottom right there. It says 15 of the students chose music. That's the total. That's not necessarily boys or girls. It's just 15 of the students that chose music. So 15 down here. Then we have 30 students were girls. Okay, so we've got that's 30 in total that were girls. There we go, 30. The next one, we've got 8 of the girls chose art. So in the art column, 8 of the girls chose art. So let's have a look. That's 8 girls there. Then we've got no boys chose art as our next line there. So no boys chose art. So I'm not going to leave that blank. I'm going to put 0 in there. And then it says equal number of boys and girls chose drama. Now we don't know how many chose drama just yet, so we'll have to come back to that one in a little bit. Right, okay, so if we start adding in some numbers then, so down that art column there, and essentially we need to find any columns or rows that have one gap in them. So that art one there stands out to me. There's 0 boys and 8 girls, and that's 8 in total. So that's 8 there. We've also got the total amount of boys. We know there's 41 people in total and 30 girls. So that's going to be 11 boys there. And then we've got the bottom row as well. We've got a missing gap for the amount that did drama. So it's 8 and 15 here at the moment. In total, that is 23. And it's got to go all the way up to 41 to get the total at the end there. So that is an extra 7 to get to 30, plus the 11 is an extra 18. Right, there we go. So now we can actually go back to that last piece of information there. It says equal number of boys and girls chose drama, because now we know that there are 18 people that chose drama. So equal numbers, half that, 9 and 9. And then we can go about filling in those last two as well. On the top row for the boys, we've got 9 in there so far. We need to get a total of 11, so that's an extra 2. And then moving downwards, okay, if I look down for the last box here, it's got a total 15. So that's going to have to be 13. Now, as that's the last box that I did, one thing that I do want to check is that these still add up to 30 on the end there. So always double check the other way on the last box that you put in. So 8 and 9 makes 17. Add the 13 is 30. There we go. And that's just a little check for you, just saying that you know you've done it all correctly. But there we go. That is my two-way table drawn. I now just need to have a look at this question. So the question down the bottom says, one of the students is chosen. So one of the students is chosen. Okay, there we go. Write down the probability that it is a boy that chose music. Okay, so it's saying one of the students is chosen. So obviously there are 41 students, so it's out of 41. And it says what's the probability it's a boy that chose music. Well, if we have a look in our table, boys that chose music, there are 2 of them. So that means that the probability of picking a boy that chose music out of the 41 is 2 out of 41. Okay, and we're going to have a look at another question in a sec where the language is slightly different. But in this question, the language said one of the students is chosen. It didn't dictate that we were just picking from the boys or just picking from the girls. It just said one of the students. So as there were 41 in total, that's out of 41. And a boy that chose music, there are 2 of them, so 2 out of 41. So it says here there are 10 boys and 20 girls in a class, and the class has a test. It says the mean mark for all the class is 60 and the mean mark for the girls is 54. Work out the mean for the boys. So when it comes to a question like this, obviously we know, or hopefully we know, that when we're normally working out a mean, we get the total, we divide by how many people there are or how many things there are, and we get our mean. Okay, so we do the total and we divide by the amount, okay, for whatever it is. There we are, on its most basic sense there with the mean. You do the total divided by the amount. Well, in this question here, obviously it doesn't actually give us the total. It tells us what the mean is, it tells us the amount, it tells us that there are 10 boys and 20 girls, but it doesn't actually tell us the total. So what we're going to do is we're going to go backwards to work out some of these totals, okay? So we're going to think about this in reverse, all right? And that is how you get the mean there, the total divided by the amount. Okay, so if we link some of these things up then, it says that there are 10 boys. It doesn't give us the mean for the boys, so that's no good so far. So that first piece of information that we are actually given in terms of the mean, it says the mean mark for the whole class is 60. Well, if we were going to work out the mean for the whole class, we'd get their total, let's call that x. We divide it by the amount, and in this case the whole class, well, there's 10 boys and 20 girls, so we would divide it by 30, and it would give us this mean here, which it says is 60. So in other words, we're looking for a number that divides by 30 that gives us the answer 60, and we can just do that in reverse. We can just do 60 times 30. So actually all we're going to do in these questions is we're going to link the mean that we're given with the amount that is appropriate for that mean. So I'm going to get rid of this little bit of algebra that I've drawn here, but obviously you could think of it in terms of an equation, but this is the sort of concept that we're going to run throughout this question, and hopefully once you actually get your head around this and why we multiply instead of divide, obviously we are doing a reverse. This question obviously becomes a lot easier then. Okay, so obviously thinking about this topic's actual name, it's called a reverse mean. Normally when you work out the mean you do a divide, and obviously then the opposite or the reverse of dividing is multiplying, and in these questions we're going to be multiplying rather than dividing to go backwards. So let me get rid of that. So let's have a look. So obviously we've been given that the mean for the whole class is 60, and we've just established that there's 30 students or 30 people in the whole class. So we're going to do 60 times by those 30 students, and that's going to tell us their total. So 6 times 3 is 18, add on the 2 noughts, that's 1,800, and that is the total for the whole class. And it's usually worth just labelling these, particularly if you haven't quite got your head around it. Let's just label that total for class. There we go. Right, so the next bit of information then, we've also been told that the mean mark for the girls is 54. Now, in terms of the question, look, there are 20 girls. So if there's 20 girls and their mean is 54, we'll take their mean, 54, times it back by that 20 to find out what their total was. So 54 times 20, there we go, and that gives us 1,080. And there we go, there is the total for the girls. And let's just label that again. Total for girls. Right, so just thinking logically about the information that we've got here, we've got a class of boys and girls. It says the total for the class is 1,800, the total for the girls is 1,080. So logically we can work out now the total for the boys. We can subtract those away from each other. So 1,800, take away 1,080, and let's write that down. There we go, take away 1,080, leaves us with 720. There we go, and that's the total for the boys. Let's label that up, total for boys. And now we can go about answering the question, because now we know the total for the boys, we can actually think about working out their mean, and that's what the question wanted. It said work out the mean for the boys. So we've got the total for the boys is 720, and in total up here, we were given in the question, let's highlight it in the same colour, there are 10 boys. So to work out the mean, just like normal, we would just finish this off by saying the total for the boys is 720. I'm going to divide that by how many boys there are, which is 10, and that gives us a mean of 72. There we go, and there's our final answer. And just thinking about what we did there, just working backwards through the question, multiplying the means by the amount to get the totals, and then using a bit of logic there to find out therefore what the total for the boys must have been, and then just working out the mean as normal. Okay, so looking at an outlier. Now an outlier can kind of appear anywhere, but we tend to look at it when it comes up on scatter graphs. So it says here, Amy records the number of children visiting a local paddling pool each day. The information from one of these days is an outlier on the scatter graph. Now hopefully when you look at it, you can see which one the outlier is. It's one that lies outside of the usual trend of points. So if we look at this one, you can see that this point just here is outside of the usual all the usual points which would normally follow this kind of line of best fit that we could draw in just there. Obviously I've just drawn a little sketch in. So that is the point which is the outlier. So we could be asked a couple of things here. Could be asked to write the coordinate, highlight it, anything like that. If we're going to give the coordinate, we've got to be very careful and just read that very carefully. So that is 24. So if I write that over here, it'd be 24 on the x-axis. And if we go across, it doesn't land on a very nice number by the looks of things, 12.5. It's in between 10 and 15. So again, you've got to read that very carefully. So using a ruler and a pencil just to trace that across. But I'm happy with that, 24 and 12.5. So the other thing that we could be asked is to give a possible reason for this outlier. And when we're asked about this, we're trying to think about something logical. We're trying to think about something in real life. So we're not trying to come up with anything silly for this. So it says here, what's a possible reason? Well, let's have a look at the information. So why on a day where it was 24 degrees Celsius, were there a lot more children? You can see up here, there's another point around 24 degrees. And on that day, it's like 42.5, so an extra 30 children. So why are there 30 less children on this particular day, even though it's hot? So let's think about a real life scenario. When are the days where children are probably going to be going to the paddling pool? Probably at the weekend. So why might there be 30 less just here? Well, maybe it was a weekday. Okay, so that is a pretty logical explanation. There's lots that you can come up with, but just try and think about one that just sounds ridiculously logical. Okay, so give a possible reason. Okay, it was a weekday, not a weekend, something like that it was a weekday, or you could say something like maybe it was raining. Okay, yeah, it's hot, but it could be raining as well. People probably aren't going to want to go out while it's raining. Okay, so lots of different things that you could think about there. The idea is, as long as it sounds reasonable, it's probably okay, but you're not trying to come up with anything silly or out of the box thinking here, just a real logical reason as to why that might happen. There we go, well done for making it to the end of the video. Hopefully that was useful and helpful. If it was, don't forget to like, don't forget to comment, don't forget to subscribe for all of my videos for the upcoming GCSEs, and I'll see you on paper 2.